Welcome to MiniWebtool. Today we're diving into a really powerful statistical idea. But first, let's start with a puzzle. Imagine you're a sports analyst and you're looking at two basketball players. You've got their scores from the last 5 games, and you have to decide who's the better, more reliable player. Okay, check this out. On one hand, you have player A. We'll call him The Rock. His scores are super steady, 20, 22, 19, 21, 18. You know exactly what you're going to get from him. Then you've got player B, the wild card. His scores are all over the place, 40, 5, 1, 50, and 4. I mean, he's a total gamble. Could be a superstar, could be a no-show. Now, you and I can clearly see these guys are polar opposites. But here's the crazy part. If you do the math and calculate their average score, the single most common stat in all of sports and business, you find out they're identical. Both players average exactly 20 points per game. So if you only looked at the average, you'd think they were the same player. And that, right there, that's the whole problem we're tackling today. The average, or the mean, it only tells you the center of your data. It tells you absolutely nothing about the spread, the consistency, or the reliability. And this isn't just a sports puzzle, right? This is a huge issue in science and finance and engineering. We need a better way to measure consistency. So how are we going to solve this? Well, here's our game plan. First, we'll go beyond the average. Then we'll fall into the comparison trap. After that, we'll figure out how to measure true consistency, unleash the power of percentage, go from theory to tool, and finally, build your new framework for thinking about data. All right, let's jump right in. First up, beyond the average. As we just saw with our basketball players, just looking at the mean can be a massive mistake. Okay, so we know the problem. The next logical step seems pretty simple, right? Let's just measure the spread. But as we're about to see in section 2, the comparison trap, it's actually way harder than it looks. So why doesn't everyone just measure the spread? Well, challenge number 1 is that as soon as you look it up, you get hit with this, a wall of Greek symbols and weird squiggles. It's enough to make anybody just close the tab and give up. And hey, even if the formula doesn't scare you, the second problem is that doing it by hand is a complete nightmare. I mean, even for just a few numbers, you have to go through all these steps, find the mean, subtract it from every number, square all of those, add them up, divide, and then take the square root. It's just so tedious, and one little mistake messes up the whole thing. But the biggest problem, the real trap, is all about context. Let's say you fight through the math and you actually calculate the spread, which is called the standard deviation. Now imagine you're running 2 factories. Factory A makes big engine pistons, average size 100 millimeters, with a standard deviation of 1 millimeter. Factory B makes tiny microchips, average size 2 millimeters, with a standard deviation of only 0.5 millimeters. So, looking at that, I'm asking you, which factory is more precise? Your gut probably screams factory B, right? I mean, 0.5 is a smaller number than 1, the deviation is smaller. But is that really the whole story? This is a total apples and oranges comparison, and it's designed to mislead you. To find the real answer, we can't just go with our gut. We need to build our understanding from the ground up. So that brings us to section 3, measuring true consistency. We're going to start with step 1, the mean. This is the one we all know and love. It's just the average. You add everything up, divide by how many things you have. It gives us our center point, our anchor. Step 2 is the standard deviation. Don't let the name intimidate you. It's just one beautiful number that tells you the typical spread of your data. A low number is good. It means your data is all bunched up, nice and consistent like player A. A high number means it's all over the map, like player B. And a quick pro tip, sometimes you'll see the formula divide by n-1 instead of just n. That's just a little correction to make it more accurate when you're working with a small sample of data. So now we have our standard deviations, but we're still stuck in that apples and oranges factory problem. And this is where the hero of our story comes in. Section 4, the power of percentage and how relative standard deviation solves this problem for good. What's really amazing here is how simple the fix is. The relative standard deviation, or RSD, is just the standard deviation divided by the mean. That's it. Then you multiply by 100 to turn it into a percentage. It's also called the coefficient of variation, or CV. And the magic is that it completely levels the playing field. The units, whether they're millimeters or dollars or points per game, they cancel out, leaving you with a pure percentage that you can use to compare absolutely anything. So let's finally solve our factory puzzle. For factory A, the Pistons, We take the standard deviation of 1 divided by the average of 100, and we get an RSD of 1%. Simple enough. Now for factory B, the microchips. We take its standard deviation of 0.5 and divide it by that tiny average of 2 millimeters, and what do we get? An RSD of 25%. And there it is. That's our aha moment. Factory A, with its tiny 1% RSD, is actually 25 times more precise than Factory B. Our first instinct was completely wrong. The raw variation was larger, but relative to its size, Factory A is way, way better. This goes to show you, context is everything. Okay, so we've solved the puzzle conceptually, but we still have that other problem. The calculation is a pain. This brings us to Section 5, from theory to tool. Let's find the fastest way to get the right answer. Now that we know the why, what's the easiest how? Honestly, this is where a simple, dedicated tool is your best friend. The MiniWebtool Relative Standard Deviation Calculator is built specifically to fix those frustrations we talked about earlier. You can just copy and paste your data in any format, commas, spaces, new lines, whatever, it doesn't care. It gives you super high precision control, which is critical for scientific work. And best of all, you get the full breakdown, mean, SD, and RSD instantly. All right, we have the theory and we have the tool. Let's bring it all together in our final section, your new framework, so you know exactly how to approach data from now on. So here's the bottom line. You now have a super powerful 3-step way to look at data. First, find the mean. That tells you the center. Second, calculate the standard deviation. That measures the absolute spread. And third, the most important step, use the relative standard deviation to compare the true underlying consistency between any two things. Now you can finally look beyond that simple average. You have the tools to analyze performance, check quality control, or understand risk in a much, much deeper way. You can now ask the question that really matters. How reliable is this number? Ready to put this framework into action? The best way to make this stick is to try it yourself. Just go to your favorite search engine and type in MiniWebtool Relative Standard Deviation Calculator to find the free tool and get your own answers instantly. Thanks for joining me for this explainer. You're now fully equipped to compare any two sets of data, no matter how different they seem on the surface. Make sure to subscribe to MiniWebtool for more deep dives just like this one.